Before we talk about solving quadratic equations by completing the square, let's review the skill of completing the square first. So the point of it is to force an expression to be a perfect square trinomial, which is a trinomial that when you factor it is just a quantity squared. Okay, so let's see how this works first, and then we'll go back and talk about why it works. Okay, so for example, if you have x squared plus 6x, what you want to do is just add half of b squared. And by b, we're talking about the coefficient in front of the regular x, not the one in front of the x squared. The one from the x squared we would call a, and then the constant we would call c. Okay, so we want to find the coefficient next to the x and add half of that squared to force it to be a perfect square trinomial. Okay, so in this particular case, the x squared plus 6x, the b is 6. So half of 6 is 3, and then square it would be 9. So then to force this to be a perfect square trinomial, you would have to add 9. But in an expression, you can't just add 9 without changing the value of the expression, because now this expression is 9 larger than it was originally. So in order to keep it balanced, you also have to subtract 9 so that you're not adding something out of nowhere. So then if you focus on the trinomial here, we're going to ignore the minus 9 for now. This is a perfect square trinomial. And the way that you would factor it would be to square root the first one. So x squared square rooted would just be x. And then it would be half of b. So half of 6 would be a positive 3, and that would be squared. And we still have the minus 9 on the outside. Okay, let's look at if you have, for example, 2x squared minus 6x. Now, when we do this, the half of b squared, it only works when a equals 1. So what we want to do in this case is to factor out the 2 first. Okay, so we have 2 factored out, x squared minus 3x now. Okay, because we factored out 2 from both of them. So then, now that the leading coefficient inside the parentheses is 1, then we can do half of b and square it. So the b in this case is negative 3. Half of that would be a negative 3 over 2. And then you would square that. So that basically means you can square the top and square the bottom. So squaring the top, so negative 3 squared gives us 9, and then square the bottom, 2 squared gives us 4. So we would add 9 over 4 in order to force inside the parentheses to be a perfect square trinomial. But again, you can't just add a number into an expression without changing the value. So we have to keep it balanced by subtracting an equivalent amount. Now, in this case, we can't just subtract 9 over 4 because this 9 over 4 is actually being multiplied by 2. So we didn't actually add a 9 over 4 here. What we actually did was added a 9 over 4 times 2. So in order to keep it balanced, we have to subtract that equivalent amount. So 9 over 4 times 2. Again, if you think about simplifying before multiplying, this 2 on top is going to simplify with 4 on bottom, so that becomes a 2. So that's really the same as adding a 9 over 2. So in order to keep it balanced, we'd also have to subtract 9 over 2. Okay, and then inside the parentheses is now a perfect square trinomial. And again, in order to write it as a quantity squared, it would be square root the first one, so that would just be x, and then half of b, so minus 3 over 2. And yes, the sign matters here. So because this is a minus b, then this will also be a minus. If this was originally a plus, then this will be a plus. Okay, and then we still have a minus 9 over 2 here. Okay, and the reason we use completing the square is because this is another method for solving quadratic equations. And I'll give you a preview in this next example here. But we're not actually going to finish solving it until tomorrow. So for example, if you have 3x squared plus 15x equals 21. In this case, because again, the leading coefficient is not 1, we can't just add half of b squared. We have to either factor out, like in the previous example first, so we can factor out a 3, or because this is an equation, we can actually divide the entire left side and the entire right side of the equation by 3, and that'll force the leading coefficient to be 1. So 3x squared divided by 3 will just give us x squared, plus 15x divided by 3 gives us 5x, equals, and 21 divided by 3 gives us 7. Okay, and then again, now that the leading coefficient is 1, we can add half of b squared. So half of b, so half of 5 would just be 5 over 2, and then square that gives us, square the top gives us 25, square the bottom gives us 4. So we'd add 25 over 4. And again, we can't just add something to an equation. We have to do the exact same thing to keep it balanced. So in these expression examples, in the same side, we would just subtract that same value. But because it's an equation, to keep it balanced, we can actually just add the same thing to both sides of the equation, because it's just like solving an equation. You can add the same thing to both sides of the equation, subtract the same thing to both sides of the equation, or multiply or divide both sides of the equation, as long as you're doing the same thing to both sides of the equation. Okay, for these two examples, it wasn't an equation, they're expressions. So in order to keep it balanced, we had no option but to do the opposite operation in the same expression. Okay, so then we have 7 plus 25 over 4. And so in order to simplify this, we would have to add fractions, and in order to add fractions, we have to have a common denominator. So 7 with a denominator 4 would really be 28 over 4 plus 25 over 4, and that gives us 53 over 4. So that means that on the left side of the equation, again, we want to write this as a quantity squared. And so you can see that again, square root the first one, that just gives us x, and then half of b. So, and because it's a positive, it's going to be plus. Half of b is just 5 over 2, and then that quantity is being squared, and then equals 53 over 4. And you can probably see by now that in order to solve this, we can solve it basically as by taking a square root, because now we have a quantity squared by itself, and then to solve this, we just square root both sides. Now we'll talk about actually solving it tomorrow. Now the last thing I wanted to talk about is why this works, right? Why you can just add half of b squared, and then when you factor it, it becomes x plus half of b squared. And the reason for that is, let's look at it. Okay, so when you square this out, that gives you x squared plus bx plus, and again, you can basically think about it as distributing the square. So half squared is 1/4, and b squared is just b squared. And let's look at what happens when we FOIL out the right side. So x plus half of b squared means you have x plus half of b times x plus half of b. Okay, and so if we FOIL this out, if we multiply the x times x, that gives you x squared, and then the outsides, x times half of b gives you 1/2 bx, plus the insides, 1/2 b times x gives you again 1/2 bx, and then the last 1/2 b times 1/2 b gives you, well, 1/2 times 1/2 gives you 1/4, and then b times b gives you b squared. These two are like terms because they both have a b and they both have an x. So when you combine them together, you have x squared plus a half gives you 1. So you just have bx plus 1/4 b squared. Okay, so basically that tells us that whenever you have a trinomial like this, in order to force it to be a perfect square trinomial, you can just half the b and then square it, and that'll force it to be a trinomial that can be written as a quantity squared.